China is projected to surpass the United States to become the world's largest air transport market by passenger traffic within the next decade, around the early 2030s. That means in the coming years, this market will demand a massive number of aircraft, especially wide-body jets, potentially in the thousands. However, Boeing is facing a serious threat of losing its wide-body market share for the 787 Dreamliner in China. But why is that? Which aircraft is threatening the 787 in this market? Let's find out. When Russia first occupied Crimea and parts of eastern Ukraine, international sanctions began to take effect. At that time, Moscow was in serious trouble, isolated and unable to easily purchase or maintain modern wide-body aircraft like the Boeing 777 or Airbus A330. Russian tie-in was on the brink of paralysis along key international routes. A dangerous void emerged, a logistical black hole between East and West. However, it was the perfect opportunity. At a secret factory in China, the joint CR929 project, now known as the C929, quietly began to take shape. This was not merely a business venture. It was a $2 billion lifeline project where two powers, both under geopolitical pressure, joined forces to create a solution. The deal seemed ideal. China would provide financing and manufacturing capacity, while Russia contributed its aerospace and aerodynamic expertise to develop a 280-seat jet meant to compete directly with the Boeing 787 and Airbus A350. But this seemingly ideal arrangement gradually began to reveal its contradictions. In 2021, as the war in Ukraine erupted, everything collapsed. By 2022, Russia officially withdrew from the joint venture, leaving the C929 project in chaos and shrouded in uncertainty. Many believed Russian aerospace engineers were forced to shift to defense projects, stalling the core development of the CR929. Rumors spread that China had demanded full ownership of Russia's engine technology, a request Moscow refused. Therefore, the alliance could no longer continue. As a result, China's COMAC suddenly became the sole leader of the program. Western observers grew skeptical. What could China possibly achieve without Russia's support? Yet on February 24th, the Chinese manufacturer made a stunning announcement. The C929 had officially entered its flight testing phase, designed with entirely independent intellectual property. Remarkably, this mysterious aircraft had already received its first order from Air China, even before anything was guaranteed. And intriguingly, Air China's executives hinted at fascinating reasons behind their immediate decision to place that order, reasons that may surprise us. When the first technical details of the C929 emerged, perceptions changed almost instantly. It became clear that this was not just a supersized C919. Beneath its metallic skin lay something far more ambitious, a true wide-body twin-aisle jet purpose-built for ultra-long routes like Beijing, New York, or Shanghai, London. With a capacity of 280 passengers and a range of 12,000 kilometers, the C929 didn't just surpass its smaller sibling. It boldly entered the same arena as Boeing's 787 and Airbus's A350. What caught experts' attention most was its materials and performance. The C929 is constructed with over 50% carbon fiber composite materials, 4 times the 12% used on the C919, matching the standards of the 787 and A350. Combined with 15% titanium alloys, the aircraft achieves a lighter yet stronger structure, reducing overall weight and improving aerodynamic efficiency. The result is better fuel economy and lower emissions, making the C929 one of the most environmentally friendly commercial aircraft ever conceived. The combination of lightness and strength grants it an impressive range of 12,000 kilometers, enabling nonstop flights that connect cities literally half a world apart. In terms of design and passenger experience, the C929 is equally bold. With a wingspan of nearly 65 meters, it even surpasses the Boeing Dreamliner, requiring a sophisticated aerodynamic configuration to balance lift, stability, and efficiency. Inside, its 5.5-meter cabin width outmatches the Dreamliner's 5.28 m and the A350's 5.34 m, promising a noticeably roomier and more comfortable experience on long-haul journeys. That extra space translates to wider seats, broader aisles, and a less claustrophobic cabin atmosphere, a key selling point for intercontinental flights lasting 15 hours or more. Beyond passenger comfort, COMAC has equipped its wide-body aircraft with an advanced digital cockpit, intelligent lighting systems, and a flexible cabin layout, all designed to enhance safety, efficiency, and passenger experience. Even the manufacturing process is a feat of engineering. Over 2.2 million individual components, 3,500 completed test assemblies, and a real-time health monitoring system capable of diagnosing issues mid-flight, a feature still missing in many aircraft today. All of this makes the C929 more than just an airplane. It's a bold statement from China's aviation industry, a declaration that it's ready to compete head-to-head with the world's aerospace giants. Indeed, beyond the technological and engineering advantages, Air China emphasized the strategic significance of this purchase, describing it as a patriotic commitment to strengthening China's aviation industry. Air China is the only Chinese carrier that flies the national flag, and introducing a domestically developed wide-body aircraft represents both our responsibility and our dedication to that role, the airline stated. By integrating the C929 into its fleet, Air China aims not only to advance its mission of becoming a world-class airline, but also to contribute to China's pursuit of high-quality growth in the aviation sector. Despite the impressive progress, some still doubt, can the C929 truly be called a made-in-China aircraft? That skepticism is well-founded. While COMAC has consistently emphasized self-reliance and technological independence, the truth appears far more complicated. According to recent reports, this ambitious wide-body jet still leans heavily on Western technology. The Chinese maker has signed a series of deals with foreign suppliers, including a partnership with Safran of France to co-develop essential systems like braking and oxygen control, and contracts with Crane Aerospace and Electronics in the United States for cabin door sensors. In fact, among the 9 core avionics suppliers, only 4 are Chinese, with the remainder hailing from overseas companies. On one hand, this reliance brings undeniable short-term advantages. By integrating proven Western components, COMAC can improve reliability, accelerate development, and align with international safety standards, crucial for obtaining certification from ESA and the FAA. Yet the other side of this dependency paints a darker picture. By relying on Western systems, the C929 becomes vulnerable to geopolitical pressures and export sanctions, leaving its future potentially at the mercy of others. A single policy shift or export restriction could stall production, delay deliveries, and undermine China's message of technological sovereignty, the very narrative COMAC has worked so hard to construct. Without full intellectual property ownership of these core systems, the C929 cannot truly be considered an aircraft of complete Chinese origin. It is instead a hybrid. One half belongs to China, the other still tethered to the West. But all those doubts may soon disappear, and here's why. COMAC has effectively silenced concerns about its dependence on Western components with one revolutionary breakthrough, the CJ2000 engine. For years, reliance on foreign engines was a major source of pressure. When the West tightened export controls, it limited parts for the C919, a narrow-body jet about 60% domestically produced but still reliant on an American-French engine. With the C929, however, Shanghai has made a decisive move to erase that weakness once and for all, taking full control of every critical technology, from the airframe to the engine. That core strength is the CJ2000, China's first domestically developed high-bypass turbofan engine and a symbol of the country's technological awakening. This is not merely a replacement for a Western engine. It is a statement of intent designed to rival and even surpass some of the best power plants in the world. Initially developed for the C919 but delayed due to concerns over stability and certification complexity, the CJ2000 is now being reintroduced with the C929 as its testing platform, with flight trials scheduled for 2029. Should these trials succeed, Shanghai will cross a historic threshold, achieving complete independence from Western engine technology in commercial aviation, something even Japan and Russia have struggled to accomplish. In technical terms, the CJ2000 is a monumental engineering achievement. It delivers up to 35 tons of thrust, matching the world's leading engines such as the Rolls-Royce Trent 1000 and General Electric GX, but with greater efficiency. Its design incorporates next-generation materials and cooling systems that allow for higher operating temperatures and lower fuel burn, translating into a 5 to 7% improvement in fuel efficiency over comparable Western models. Physically, the CJ2000 is an absolute giant, with a 3-meter fan diameter and total height of 4.55 meters. It even surpasses the 33-ton GX engine that powers Boeing's 787 Dreamliner. Its composite fan blades and advanced noise suppression design make it not only powerful, but also one of the quietest engines ever built in China, reducing cabin noise levels and vibration significantly. At cruising altitude, its fuel consumption is notably lower than that of many international rivals, giving it an edge in efficiency and long-range performance. Moreover, capable of speeds up to 980 kilometers per hour, the CJ2000 combines raw power with refined engineering, a balance of strength, speed, and silence that redefines what a Chinese-made engine can achieve. For the Chinese maker, this is a strategic and symbolic milestone. The CJ2000 transforms the C929 from an ambitious newcomer into a formidable, fully self-reliant contender on the world stage. It dispels the long-standing perception that China must depend on foreign technology for its most critical systems. Unsurprisingly, Western media now acknowledge the C929 as a legitimate rival to Boeing and Airbus, and the CJ2000 as the engine that could finally tip the balance. With its high domestic content, breakthrough propulsion technology, and the political force behind China's industrial ambitions, the wide-body aircraft powered by the CJ2000 isn't just another airplane. It could reshape the future of global aviation and mark the moment when China's aerospace industry truly comes of age. Conclusion: if the C929 succeeds, it could become the biggest disruption to the wide-body market in decades. With its long range, high efficiency, and breakthrough domestic engine, this aircraft stands poised to challenge the dominance of Western giants, especially Boeing's 787 Dreamliner, the very model it was designed to rival. For airlines seeking alternatives amid rising costs and political tensions, a competitive Chinese option could be transformative. And if COMAC manages to deliver on performance, reliability, and certification, the C929 may not only win domestic loyalty, but also carve out a share of the global market, signaling that the age of Western monopoly in wide-body aviation might finally be nearing its end.